Hi everyone, welcome to the sixth tutorial that is testing the sensors for your TinyML third module. We're going to talk about different sensors that are there in the Arduino device itself and see how we can test that all of those are working, and then you can go ahead and use those for your particular applications. Okay, let's start. So, so we've already done the TensorFlow Lite micro test in the previous tutorial. We're gonna test the following sensors in this tutorial. We're gonna do IMU, which is the inertial measurement unit, which detects motion in 3D space. We have the camera, which is the OV7675 module, which is already there on your shield. And then we have the microphone. These are few of the sensors that are present in the Arduino BLE, and then there are more sensors like a proximity sensor, a color sensor, and temperature sensor. All of these sensors are there that you can use for your projects and for further applications. So let's go for it. We have testing the sensors, and we'll go to the Arduino IDE. So to open these, you can go to File, Examples, and then open up TinyML ESE360. By now, you must have this library already installed in your IDE. So you can go to TinyML ESE360 and click on Test Camera, Test IMU, and Test Microphone. It will open up 3 different sketches for you. And you just have to deploy it to test it out. So we have test microphone, we have test IMU, and then we have test camera. Okay. So let's start with the microphone first. So we already have this slide, the sketch written for you. Oh, I think this is the IMU one. So that this microphone. So yeah, we go ahead and deploy this particular sketch onto our hardware device. You see the similar functionality, void setup and void loop. The setup just initializes the shield, which we already have. It does, it starts a PDM on receive for serial data for the microphone, and then it prints some standard, comments that you need to, make sure that you do for your program to run. So we'll wait for it to deploy. And you can see that the code is pretty simple. It's just a bunch of if statements where it reads the input from the serial monitor, and then it will plot it on the serial plotter. We'll walk through what serial monitor and plotter is in a while. And we'll also see a demo of how we can use those for debugging. I'm just going to go to port and COM15 just to make sure that the Arduino Nano is already there and being detected. Then we can go to, so when you go to tools, we have 2 options, serial monitor and serial plotter. These are the 2 communication platforms through which we can visualize and monitor the data that our Arduino is sending back or be sending it to the Arduino. So first of all, let's go to serial monitor. This is the pane which has all the like the basic stuff, and it just prints out numbers which can correspond to raw data for that particular sensor. So to test the microphone, if the microphone is running or not, we're going to open the serial monitor. After deploying this particular sketch, we're going to click the button on the shield. And you see that there are a bunch of numbers going around. Now, it doesn't make much sense of what these numbers are, but you see when I stop speaking, the values of the numbers will reduce significantly. And when I start speaking, the value goes into hundreds, like -300 or something like that. It's too, difficult to tell what's going on. So let's close up the serial monitor and open up serial plotter. And now you see that there's a visual representation of what sounds that your microphone is detecting. So if I speak louder, it's gonna be like that. And then if I don't, then there's a static noise which it's reading from the background. So yeah, that's pretty much it for testing the microphone. Let's go ahead and deploy the camera. Well, let's do the IMU first. So we have the IMU here. We will go and do a similar kind of step. We'll go and click on upload for this sketch. We'll wait for it to upload. You see that there are some comments which are already there. Welcome to IMU test for built-in IMU for the Nano 33 BLE sense. You have to you have to send some serial commands, which is either A, G, or M for the accelerometer, the gyroscope, and the magnetometer. The accelerometer measures the accelerations in 3D space. The gyroscope measures the angular rates, and magnetometer measures the magnetic field that the device is placed in. And we have a similar kind of test where we're going to have serial monitor and serial plotter. First, let me set the port again. Yep, that is. And then we'll go to serial monitor. See, it says all of this. So in this text bar, it can be at the bottom for you if you're using a different version. But we can go ahead and write a particular letter and press enter. And you see that the values are there. Since the Arduino is on the table and not moving, the acceleration values for all the three axes are pretty low. But if I take this Arduino and if I start moving it, you see that the acceleration is improving significantly. And like in Z direction, X direction, Y direction, all of that. So we have a basic idea of what this is doing. Let's see how we can visualize this. So go to serial plotter, you see it's on the ground. And then when you start moving it, it's not. It's pretty random and you can do random stuff with it, So yeah, this is how you can visualize. For the other two sensors, it's kind of the same. You go to serial monitor and you click on G and you send it. And you wait for some more time. And then you see the angular rates are there. And now you'll be able to see it. One more important thing that you cannot open serial monitor and serial plotter at the same time because there's only one line of communication between your laptop to your Arduino device. So yeah, please be careful to close the serial monitor and then open serial plotter again. So now you see that it's much more jittery because the angular rate sensor is not that perfect, but the values are gonna be, so it's basically how fast I'm turning this, like the rate of 3D rotation is angular rate. So that's pretty much it. Next, let's get into testing the camera sensor. So open up the camera sketch and deploy it. This one takes a little bit of effort, and we're going to go through what it actually does. So in this course, you have the OV7675 module, and that's what this has been set up for. So yeah. What the test camera Arduino sketch is going to do is that it will output some raw hexadecimal images, hexadecimal values, which won't make much sense. And the serial plotter is not designed to, encode those values into a visual plot. So we're going to use another hack that we have with us to visualize the images that are being recorded by this camera. So let's go to serial monitor first. And we see that it says that you have to click the the button on the Arduino, which is this button on the shield, and to do a light capture. So let's turn the camera around so that it sees our box, and then let's click this button on once. And you see image data will be printed out in 3 seconds. And this is the huge value of the image data that's being printed. Now, this doesn't make sense, but for all of it to make sense, we need to do one thing. So we'll wait for it to print out, and then we have to copy this entire value. So I think it's pretty much selected, so I'll just do a Control C, and then just check everything selected. Yep, everything selected. Yeah, so you just copy this by doing like selecting it and then pressing Control C or Command C for Mac users, and then you can go to the TinyML course plan again, and there you'll find a utility which says util OV7675 image viewer. This is a collab that has been set up for you to view all the hexadecimal images. So we'll just go and run this notebook. Then the next one, it says that copy the output of the serial monitor to the variable below. So we'll just paste everything here and it's nice and easy. It's there. We'll just run this particular tab. Also, it may take some time because like the value is too big for the clipboard. Yeah, so it says that it's slowing down Firefox for us, but we're gonna have to, yep, it's there. And you run that cell. After running that cell, you can go ahead to the next cell, and there you go. We have an image. I didn't get the entire TinyML 360 in the frame, but yeah, it kind of explains what I was trying to do. So yeah, this is it for the testing of all the sensors. And thank you so much.